Looks like we're here. Make sure we're live on YouTube. All right. I guess I don't need to show that on stream. It doesn't really matter though. But okay, we're good. Okay. So let's start digging into this real analysis stuff. Wait. I didn't bring up the right one, did I? Oops. I think this is the last real analysis. Oh, that's right. I didn't have it download on this computer because my power was out. Okay. Let me go download it. 1 minute. Ugh. It's like, this looks a little too familiar. Keep it up though, just in case here. Okay. This is what we want. You know what? Oh shoot, where did he post it? There's some link. Oh shoot, I don't know where he posted that Stack Overflow link about separated. We had a whole discussion about the definition of separated here. You know, it had a potential issue. I don't know where that Stack Exchange, so Stack Overflow or whatever link went though, unfortunately. Oh well. I can always ask someone later. Okay. Let's start looking at the questions, I guess. So I wanted to take another look at number 1 here because I think I understand how, because at first when Bob just kind of like did it, and I think I understand how, but I'd like to put it, I had a different idea for how we could potentially prove it, and I want to try and pursue that and see how it looks. Because I think I could make, it's like, it wasn't exactly in the terms as in the terms that we were like using in class, I guess, if that makes sense. But I think it wouldn't be that much of a leap to get from the things we've been saying in class and to get to how Bob did it. I just want to see a little bit of a different approach if it still works. All right. So the sum of two continuous functions, f maps d to r and g maps d to r is continuous. So, well, I guess since they asked prove or disprove, I'm definitely on the prove side of this. I don't think it's going to be not true. So, Jed first. Nice. I need to scroll up and look at the definition of continuous again, just to make sure that I do things a similar way. I know that the browser is a little bit messed up, but I'll fix it in a minute. F maps D to R, where limit as x approaches. We're saying k? K. So f of k for all k belongs to D. Okay. It goes on a bit more, but yeah, I know, Jed. I was just too lazy to actually fix it. That's what I wanted the browser to be on, so it's like copying it down quick. So Now we want to prove that the sum of f and g, which are both continuous, is also continuous. So I was thinking, look at this equality and try and prove both sides of it. So I think, let's just take h of x equal to f of x plus g of x, just to give their sum a name. So we want to show that the limit as x approaches k of h of k is, oh, h of x. I always get that part mixed up. Is equal to h of k for all k belongs to D. And so what I was thinking is that the right side of this equality is pretty easy to show what it is, just based off our definition. Is equal to f of k plus g of k. Because that's how we've defined our h of x function. Now the limit part is going to be, I assume the part takes a bit more work here. I never changed out the ink in my blue pen, did I? I literally had 2 days without electricity, and I forgot to do something that doesn't require electricity. Isn't that great? It only takes 2 seconds, though. You know, I'm feeling blue, so I want to be able to use my blue marker. All right, just give me like 1 second here. Blue is somewhere around, is that blue? Doesn't look, yeah, it is blue, okay. How do you do this again? You face it up, unscrew it, throw out the old one, okay. I need to do this by the trash can just so I can like dump it out though. It's probably, open up the new one. Okay, face it up, unscrew the bottom. Are you gonna come out, buddy? Just gotta twist it a bit. There we go. Then just basically shove the new one in. That's what she said. All right, that feels like it got shoved in the appropriate amount. And wash my hands because I accidentally touched the inside of my trash can. Even though it's, you know, I just replaced it, so the bag was clean, but it still feels a little gross. Okay. Now we're all good. Okay. So this is the part that we want to investigate here. We want to see limit as x approaches k of f of x plus the limit as x approaches k of g of x you know, actually, isn't this really simple? Because by continuity, this is equal to f of k plus g of k. So well, have we shown that the limit? We need to show the limit of h, I guess. So I don't. Maybe that's not the exact thing that we want. Actually, maybe it is. Actually, no. This is using. I want to slightly rewrite this because I think I jumped the gun a little bit, and I'm implicitly using a limit property that we haven't necessarily shown for continuous functions. So what I want to do here is say that the limit as x approaches k of h of x is equal to the limit as x approaches k of f of x. Well, I mean, this step is valid. The step that we haven't necessarily shown is that we can distribute the limit to f of x and g of x individually. And I think we do need that. Because then I can use my same argument with, like, you know, by continuity, this becomes f of k plus g of k, and we have gotten that the two sides are equal. That's the strategy that I wanted to use, but it's this little step here that probably needs justification. My manga way though. I have an idea for how we can do it. I think we need to go to epsilon delta though. Okay. So limit as x approaches k of f of x plus g of x. Actually, I wonder if we want to start with this, with basically this side of the equation or that side of the equation. I think we need to start with that side of the equation because we don't know anything about their sum yet, I don't think. Like, we're trying to show something about the sum when they're both inside the same limit. So it makes sense to start with the one with them separated. Excuse me. Oh! Sorry, I forgot to turn off the timer before I started the stream. Okay. So let's take a look at the limit of f of x. For all epsilon greater than 0, there exists delta greater than 0. Such that for all x minus, I guess we're using k here, less than delta. I believe it's something like this. F of k minus, we'll say L1 is less than epsilon. I think that's how we write the epsilon delta limit. Let me, I guess that's a good thing that I have problem set 10 up here. Yes, okay, this is just the definition of element. And then let's call this epsilon over 2, because my intention is going to be to add these two together. You know, I'm writing my epsilon two different ways, aren't I? It's the same thing for g of x. I guess k1, k2, right? Well, no, it's the same k. Technically, they can be different deltas. Hey, SPQ. So you can say delta 1, delta 2. Because now we're starting to set, now we're basically going towards where, like, how like Bob did this yesterday. And so we can just take the minimum. Take delta equals min delta 1, delta 2. How exactly am I going to phrase this? I'm going to add these two and then do some triangle inequality stuff. I just want to phrase it right. For all epsilon greater than 0, there exists delta 1, delta 2. There exists a delta greater than 0, such that x minus k less than delta. K minus L1, oops, it's absolute value, plus g of k minus L2 is less than epsilon. This will, and that's what I want to, hopefully triangle inequality is actually helpful here. This is greater than, okay, yes, I think it is. Because the direction of the inequality is going to help us here. Because this is, we could write another statement over here that it's greater than or equal to these two things combined. So this should work out the way that I want. Plus g of k minus L1 plus L2 is less than epsilon. which by how we've defined it is h of k L1 plus L2 less than epsilon. Okay. I feel like I've now justified this step a bit more. I hope that's okay. This is basically what I wanted to do yesterday. Okay, so now we're ready to go back down here. So the limit of h of x is equal to that, which, as I've now justified, is equal to that. And then this needs one more line. Which equals f of k plus g of k. Good. Therefore, the limit as x approaches k of h of x is equal to h of k. Box. Is there anything wrong with this? Or can I make anything more clear here, maybe? I already put the box, so this has to be perfect, right? I hate how, like, the green is encroaching on the black here, but just draw the magical line of separation. Actually, and so what, the sum of two continuous functions. Maybe, okay. We can write a conclusion a bit better, I think. F plus G is continuous. There we go. All right, I think I'm happy with this. I would like to take a screenshot and put it in Zach's Discord. So let me go and do that quick. Let me hide that for a second. Get my screenshotting tool. Bring up my stream. Okay, there we go. Continuous on D. Oh, that's a good point, Zone Ranger. Let me do that. Because I'm not good with the like rigorous math language, so I definitely don't mind being anal so I can learn. Okay, let me get a screenshot of this now. Once the stream catches up. Come on, stream. There we go. Okay. Now prove that minus f comma f times g, and if g of x is not equal to 0 for all x and d, then 1 over f is continuous. Yeah, that's true, Zone Ranger. I didn't even think about that. Is that even true, SPQ? Wait, prove that minus f and f times g. Actually, it might be context dependent, because we have had things where like they only mean continuous on D, but I don't know. It doesn't hurt to have it. Either way, let me just go and post this in Zach's Discord quick. Prompt one, in terms that I was more familiar with. The actual proof is in black on the right. The green on the left is justification for one of my steps, underlined in green. And get that. Okay, good. Oh, processing. Is it going to actually post setting? Okay, thank you. All right, let's look at what I want to do next. So I definitely wasn't feeling super comfortable with the stuff that we did yesterday, and it's a nice opportunity to kind of like catch up on things. Being super anal is always beneficial. My webcam's cleaned my desk over the weekend, and that involved like taking my webcam off and like moving on my camera and like my whiteboard and stuff, and things aren't quite right still. Okay. Anyway, we went through these. I don't know if we had that satisfying of an answer for H. The only kind of connected set in R that I can think of is an interval. Because if it's not an interval, then aren't you making some kind of hole somewhere? And that's kind of what and Bob kind of, I think Bob proved it for intervals, but it's getting a little bit like tricky. I don't know if I want to investigate that one too much further though. How's it feeling about this one? So this one, we kind of got the idea, because for number 3, the point is that you can't just set e to the x plus sin x equal to 0 and solve for x, because good luck solving this for x. Maybe, I wonder if it's possible with imaginary numbers. Okay. I want to see if this is possible if you use the imaginary definition of sine. I know it's a real analysis class and I shouldn't, but like, I just want to see. Actually, two real solutions? Yeah, that makes sense. But I wonder if you did use the imaginary definition for sine, if you could still get those real solutions. What is it? Sine imaginary definition. I remember it's not that hard to just find it with Euler's formula, but here it is. Okay. I don't know, I feel like it's kind of ridiculous to even try this, but I just want to see what happens. No one tells Zach that I'm going to use imaginary numbers. Yeah, I feel like the more that I think about it, I feel like using imaginary numbers isn't going to help solving it algebraically, but I just want to see what the exact issue is. I think the issue is going to be the coefficient, the over 2i part, because that would prevent you from equating exponents. I guess you could still take the ln of each side, though. Yeah. Oh my god. Okay, this thing is getting sprayed. Bad whiteboard. Boy. Dude, this is why I don't write on the left side of my whiteboard. Okay. So, all the exercise that I get to. That's not true, but... Okay, so yeah, I just want to see what happens with can we solve this with imaginary numbers? Yes or no? So plus or minus? Minus. So my idea is to take, I guess we can do that one. Oh. That's going to be an issue. I don't... Maybe you need a complex logarithm to do the ln of that. Maybe I want to make... No, we can make that one the negative one, I guess. I don't really know how complex logarithms work, so I kind of want to avoid that. We can do this and just reverse the signs. Oh wait, but no, that's a negative number 2 though, right? Unless x is negative. And we only need x. I don't think there's any positive solutions for x anyway, so maybe we can. Oh wait, I mean technically that should be capital L log, right? I know very little about doing stuff like this, but let's just pretend that this is right. Well, actually, we can't do anything with this though because it's subtraction, can we? Like, we're just stuck with that. Maybe that's where we get stuck. Okay. Well, would it be helpful to write it? E to the minus ix is just a complex number. Could we write it as like a rectangular? I don't know, this feels not right. But no, I don't know how it works with x. Okay, never mind. I don't think maybe there is a way to actually do this. I don't know what it is though. And I feel like I'm really getting out of my depth with complex variables here. Okay. Let me see what we did in class for this one though, because honestly I don't really remember it that well. We were basically talking about the intermediate value theorem, even though we haven't actually like gone over it in class though, so it's it was a bit hard to have the discussion because it's something that we all knew but we weren't allowed to use, so so yeah, I don't know that we actually proved it. We did convince ourselves of it. The idea being that when x is less than 1, e is less than 1, but sine is potentially equal to 1. And that's important because that means you can show that the function is both above the x-axis and below the x-axis. And so it must cross 0 if it's continuous. And this involves the idea from problem 1 where the sum of two continuous functions is also continuous. because e to the x and sine of x are both continuous. Is there a way? I don't know, it feels like you just have to prove the intermediate value theorem, which... So I don't know how you would do this without just proving the intermediate value theorem, the more I think about it. Let's just look at a proof. And see how that works. Maybe QMath would have it. I guess I assume you prove it by contradiction. I don't really know how it would work though. Like I don't really know where to necessarily even start with that. Hmm. We could prove it. Is it easy? I remember Bob saying it was kind of hard. Connected subsets of R are intervals. I think we basically said that as part of question 2. Wait, it's so pretty straightforward. It's not good English, but you know. So the f of A is less than L less than f of B. Hey, Anshuman. Yeah, I remember you. It was only like 2 weeks ago or something, I think. That I remember seeing you last. Well, thank you. Assume that f of A is less than L is less than f of B. Consider the following set. And Schumann, I'm not very good with chemistry, I'm sorry. Sometimes there's people who are good with chemistry, like around in like the Twitch chat or something, but I have a hard time like thinking of a specific person. Hey, Lamier, if I'm saying that right, how's it going? How? So we're only taking. It's a one-liner? It's good to hear. How much do you earn monthly, sir? Just from like on YouTube, I earn nothing because the channel's too small. On Twitch, it's like 50 to $100 a month, I'd say, depending on the month. And Lemmy, you're welcome to hang out, but if you do have a question, please like let me know. Right now I'm just doing some like studying for fun. Notice that A is non-empty. I'm a little like if fx is less than L, then like isn't this interval going to be the same thing as A to L? Or f inverse of L, I guess. Well, thank you, Anshuman. Suppose f of d is not connected. All right, f of d equals a union b. Where a and b are open and okay, yeah, the definition of separated. Oh, graph theory? That is not... I don't know basically anything about graph theory. The only person I can think of who might, and even then I can't promise it, is Ian Stuckey on Twitch. Even then, I don't know what their level of knowledge with it is. And I promise you that's me just typed in chat. For whatever reason, it just logs me into my other chit channel. But the second person in that list, Ian Stuckey, might know about it, but even then, I'm not completely sure. Graph theory is a bit of a tough one. All right, so back to SPQ's proof. Right, f of d equals a union b. A, b are open and non-empty, which is the definition of separated, or being not connected. Then f inverse of a and f inverse of b are open and non-empty. Moreover, f inverse of a union f inverse of b is equal to d. Or I guess, I'm saying inverse, but it's actually the pre-image. Or I don't know if there's really that much of a difference in this context, but then D is not connected. Unions are disjoint. Right. But suppose f of D onto R is continuous. When did we say that D is connected? You said suppose f of D is not connected. Is D being connected implied by being continuous? I don't think it has to be connected, though. Okay. Image of connected is connected. That makes sense. And if it's connected, then it should... Okay. I guess I see the idea. I'm still not sure of the mechanics. Let me read it again, though. Suppose f of D is not connected. Then you can write f of D equals A union B, where A and B are open and non-empty. Then f inverse of A and f inverse of B are open and non-empty, because it would have to match the input. Moreover, f inverse of A union f inverse of B is equal to D. So you're basically just taking the function, plugging D in, and then doing the inverse on A and B. I guess that's all that's really happening, but it's how we're interpreting that. And D equals f inverse of f of D equals f inverse of A union B equals f inverse of A union f inverse of B. Inverse A. Okay, and okay. And the thing I still was like trying to grasp that that the issue is that F inverse A union F inverse B is supposed to be empty because A and B are disjoint, but we found that they're equal to D here, and that's the contradiction, I guess. Okay. I hope at least. Well, if A and B are disjoint, are F of A and F of B necessarily disjoint? I'm not sure. I don't know. I kind of want to read this proof too to see if it like. I assume it takes a different direction. Like I said, I already don't understand like this part of it. Get this one. Hey, Spot. I'm just gonna say Spot 'cause I don't know how you pronounce that. Can you do a matrix? What about matrices? I can do basic things with a matrix. If you're getting super deep into linear algebra, though, then I have a hard time helping you. If it's easier, you can to post a screenshot. You can put it in my Discord as well. Equations. Yeah, if it's just like solving system of equations, I can definitely help you with that with the matrix. The flag, hey, also hi Tolkas. The flag that's above me is from a game called Fallout New Vegas. I kind of wonder if I should even keep it on stream because people keep thinking that like I'm a rebel and I want independence for California, but it's a faction in Fallout New Vegas. And you know, it's the California state flag, but the bear has two heads because in Fallout New Vegas, the world's been nuked, everything is radiated, and animals have mutated. But it's from a video game, basically. Yeah. I mean, there's actual Californians who want like independence too, but they're kind of few and far between. It's a spot. If you need to post a question, just let me know, and I'll probably take a look. And hey, Amon on YouTube. Hey, sir, I'm struggling with math a lot. I think my fundamentals are clear, but currently I'm doing data science first year, and math is hard as hell. Since you're first year, I bet well, it depends on the actual class, but I have a good chance of being able to help with like calculus or differential equations or things like that. But yeah, no, if it was easy, I think everyone would do it. It's something that's worth sticking with. It's the flag of the New California Republic, place where I will request a political sign when it gets established. F of x is in A and B simultaneously. All right, I never understand proofs on the first try, or I almost never do, but I think I kind of understand what's happening, and I just need to like sit on that for a little bit. I am interested in like a proof that's probably more along the lines of like what a calculus student would think, because that's what I'm more familiar with, but okay, I don't see a question being posted to me yet. I'll happily switch over once I do see one. Maybe we should just look at a different one though, and I'll tackle intermediate value theme a bit more another time. All right, so Zach did warn that 4 and 5 aren't necessarily the most relevant to what we had discussed. Let's at least read what they are. And see if they're, I guess, of interest. So 4. Roadmap for topics of Math 1 and Math 2. Is that what the actual class is called? I have no idea what that would be about. I have a feeling that it'd be math that I can understand. It really depends on the actual math that you're doing, though. If you have a specific problem that I can help you with, you can type it out there in chat or put it in my Discord. There's a math homework help forum, which is probably the best place to post it. Oh yeah, Tolkien. So we were basically talking about the intermediate value theorem. Math 1 is algebra and trig, and Math 2 is calculus. Oh yeah, I can definitely help you with all those. Yeah, if you think you're gonna need help, like as you study, my schedule is today's a special occasion because I missed my stream yesterday, but my normal schedule is Tuesday, Thursday, Saturday, starting at 1 Pacific time, basically an hour ago, whatever that is in your time zone. And that's when I'm doing questions live. If you do ever need like offline help, just post the question in my Discord and we'll try and get to you. Hey, Bob. Yep. Send it. Oh, shoot. It's a docx. I can't easily open a docx file. Is there any way that I could bother to maybe just take a screenshot of maybe a question or two at a time? Let me... So I just made a little thread for you, and I added you in its spot. If you don't mind, Jed, it was posted in the general on the Discord spot. It's a little bit. I mean, Jed might do it too, but it's a bit easier for me if I can have just like a screenshot, if you don't mind. Okay. So I'm trying to think of a way that I mean, I guess I put it into like Google Docs or something, but I don't have like a program on my computer to actually open up a docx file, so. And Amon, if you're gonna have a question too, just post it in the math homework help like form if you don't mind. So Spot, I made a thread for you and I added you in it, so hopefully you see it. If you don't mind, just take a quick screenshot of that file and post it in there. It's a lot easier for me to work with that. Actually, Jed might. Oh, you're trying? Okay. No worries. I don't mean to like rush you. And we might have Jed get to it first, so. Oh, wait. Prove the following properties of limits. Oh, wait. So I actually did that one. Okay. Let's see. I see. Okay. It's in Spanish, which I like a challenge. Thank you for doing that, Spot. Okay, so study if the matrix D has an inverse Y. If it does, then calculate it. I assume that's like determine if the matrix D has an inverse Y, or just has an inverse. I don't know if that's so. It says 2 is Aragon. Oh god. Oh, that's super weird that it came out like that, Jed. Thank you for trying though. So I guess we need to calculate D here. Because, well, we're gonna get a 3x3 matrix, I think. Hey, Lindsay. Chemistry? Oh, shoot. I wish I could help you. I'm not very good with chemistry, though. And I don't know of anyone who's around in chat right now who is good with it. I'm sorry. There's another person before who needed help with chemistry. Oh, you know what? I wish I thought of this sooner. There is a there's a pretty big Discord for chemistry that will take math questions. I'll give you the link to it, but it's this one right here. You might be able to try. Oh, or organic chem. Yeah, I definitely can't do that. The people in that Discord might be able to help you out. I never tried it for myself because I don't want to study chemistry that much, but it is a decent sized chemistry help like Discord. But yeah, I'm not good with chemistry for myself, so I'm sorry about that. By Gauss or determinant. Okay, that's right. It's pain. Yeah, I've heard. My roommate in college was or is a chemistry major, but you know we were studying like years ago, and he complains so much about organic chem. Is there a way to just tell that a function doesn't have an inverse by looking at it? Determinant is unequal to 0. Okay, yeah, that's it. Okay. Where is it? Here we are. Let's just see what D is first before anything else. Yes, but I'm gonna have to Google to remember exactly how, but I know generally how you get the inverse. It's gonna be a 3x3 matrix, I think, which is gonna make it a little bit harder. Will we get a 2x2 actually? I don't know. I need to actually see, because I'm not that good with linear algebra. This is... I know I can do this. It's just gonna require me doing some like Googling and maybe messing some things up. So D is A times B transpose minus 2I. So let's just calculate this first. So A is 3/2 minus 2, 1, 2, 0, 1, negative 1. Penn Center did this the other day? Oh, okay. Yeah, Penn Center just helped me out with the linear algebra like last week too. And then we have to transpose B. So the 1 stays in the same spot. The 0 comes down. 1, 2, negative 2. 1, 0. I think I transposed that right. Because the first column becomes the first row. Second column becomes the second row. I think that's okay. And then, so, oh shoot. Okay, so this is 3/2, and that's 2/3. So the product of these is going to be 3/3. So our identity matrix needs to also be 3/3, and it's 2 times the identity. So 2, 0, 0, 0, 2, 0, 0, 0, 2. This is the equation we have to work through. So I guess let's start by doing this multiplication here. We're expecting a 3/3 result. Oh God, okay. So to do this multiplication, we take the first column, dot it with the first row, and it'll be the upper left element there. So it'll be 1 times negative 2 plus 0 times 1 is just negative 2. Now for this one, we take the second column with the first row, right? Yeah, so we get negative 2 plus 1 is negative 1. And then the third column with the first row, negative 2 times negative 2 is positive 4 plus 0. Okay, and now we do the same exact thing with the first column, but now with the second row. So 2 times 1 is 2, 0 times 0 is 0. So 2 plus 0 is 2. Second row, 2 times 1 is 2, plus 0 times 1 is 0, so we get 2. This row, that, or this column, that row, 2 times negative 2 is negative 4, 0 times 0 is 0, so we get negative 4. Now, with the last row, we repeat with each of these 3 columns. 1 times 1 is 1, plus negative 1 times 0 is 0, so we get 1. Hey, Bob. Oh, shoot. I really was just thinking about your YouTube channel. I don't know if I should have subbed. I think I'm subbed. I'll have to check though. So yeah, second column times the last row. 1 times 1 is 1, plus negative 1 times 1 is 1 minus 1 is 0. Now last column, negative 2 times 1 is negative 2, minus 1 times 0 is 0, so we just get negative 2. Okay, good. I hope I'm not doing this multiplication too fast. I'm assuming that you already know this, but if you don't know how to multiply 2 matrices, please let me know. You don't do anything mathy on YouTube? Oh, okay. I thought you showed me like one video you did about a math thing. I can't remember though. Okay, so now we have to do this matrix subtraction. Thankfully, matrix subtraction is a lot less work. You take that one minus that one is negative 4. Negative 1 minus 0 is negative 1. 4 minus 0 is 4. 2 minus 0 is 2. 2 minus 2 is 0. Negative 4 minus 0 is negative 4. 1 minus 0 is 1. 0 minus 0 is 0. Negative 2 minus 2 is negative 4. Okay, that's our matrix. That's our matrix D. What's my astrology sign? I think I'm Pisces. You do know? Okay, good spot. I'm glad I wasn't going too fast then. You did the 1,000 cows explanation? Oh, okay. You too? Who? Oh, that's right. Your birthday is like March 5th, I want to say. It's something like that. And Spectries is something really close to that too. Right spot. March 3. Ah, shoot. I was close. My bad. All right. So yeah, to get the inverse, that's something we need to Google. I'm not saying my birthday. That's a trade secret. You're a rooster, Tolkus? So we can get the... Oh, God. Inverse of 3x3 matrix. I think what I'm going to do is the Gaussian, where you do like an augmented matrix with the original and one in the identity. Or you might do identity and then the matrix. I don't remember. Roosters. You pray that. Yeah, Jed, I think that's what you want to do. Yeah, just do this. That's really easy. On March 15th? Yeah, you can do that, Bob. That's the basket weave method that Penn Center taught me. I don't want to do it that way because that's not a way that Spot mentioned to do it. Oh my god. Just show me the identity way. Really? All right, what's BYJU? Complement of the set of invertible matrices has Lebesgue measure 0. It's fair enough. I can't say that I know how to do that. Oh my god. Why are they... Just show me the way that I know how to do it. So you mentioned doing the inverse either by the determinant or with row manipulations, and there's a way that I've heard of to do it that's not too hard, but it's not one of those two ways that you mentioned, so I just didn't want to do it that way. Dude, why don't they just... I'm thinking of a very specific way to do it, and apparently none of these things are showing me. Okay, what we can do is how do you even get these tiny matrices? Removing the row and column. Oh! I guess this might not be that bad. And you have to transpose it. Wait. The adjoint. I mean, I could do it this way. Every site is screaming at me to do it this way. Oh, they're describing it in words and not actually saying... Okay, so... Spot. Does... This way, is this a step that you're familiar with in finding the inverse of a matrix? Because we could do it this way too. I haven't seen this before, but I think I know how they're doing it. And if you're not familiar, okay, you have this. Okay, so maybe we'll just do it this way. So I think I know what the goal of this is. It's going to be a lot of work. So we need to get this matrix, the minor matrix, do a whole bunch of 2x2 determinants, and then transpose it, and then divide by the determinant. Let's start with getting the determinant of the original 3x3. Oh, wait. Hey, Spetri. The Unterdeterminaten Verfahren. That's exactly what I was thinking, Spetri. You stole the thought right out of my mind. Hey, Gilbert. You're right. Make an automated matrix the identity in the right if you're American. Oh, do non-Americans do it a different way? It's only one part of the exercise to the exam in less than an hour? Oh my gosh. Spot. That's a lot of work. Determinant spectry? But I think we'll do it the other way anyway. The goat with the horns. I think Spectry is going to be Pisces. His birthday is really close to yours. A lot of exactly, yeah, a lot of numbers. Okay, so let's start. Wow. Okay, let's start by dropping a marker. Second step, let's just get the determinant of D. -4, -1, 4, 2, 0, 4, 1, 0, -4. So I'm going to eliminate along the last row, I guess, because it'll be plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay, so using this row as our elimination row, we block off that column first. We get -1, 4, 0, 4. Now, because there's a 0 there, we don't have to worry about it. And then we do plus -4 times -4, -1, 2, 0. That becomes -4. That becomes -2 times -4 is +8. So I get +4 for our determinant. So actually, oh wait. If it's not equal to 0, does that mean we don't, there's no inverse? That would save, that'd be great. Let's plug this into Wolfram Alpha. If that is equal to 0, there's no inverse. Oh, I had it backwards. Oh, it's Aries? I don't know when the cutoff is for, it's -4? Oh no. Did I flip a sign here? Let's plug it into Wolfram Alpha. Wolfram Alpha knows all the answers. You have an exam tomorrow, don't wish you luck. All right, well, have fun then, Spetri. It is -4, you're right. So what did I do wrong? Did I get my signs wrong? It's plus, minus, plus, minus, plus, minus, plus, minus, plus. With a cute pen, exactly, that's the most important part. All right, so it absolutely is -4. What's the issue? Did I copy it down wrong? No? Oh, wait. That is -8. Because it's 0 minus -2, which becomes, no, it is +8. What did I do wrong? Second line? Oh my god. I did copy it down wrong. Frickin' hell. Okay. So what, this needs to be a -4? So that's +4? That's, I still did something else wrong though, right? That needs to be a -8. But why is it -8? It's in diagonal. I agree, Spectry. Ugh. So we get... Oh my god, okay, well, let's just write this out the hard way. 0 minus -2. Comes -4 times +2 is -8. So it is just a... Okay, there. I think I'm right now. I just can't do basic math. Do you think that's going to be a problem? I don't. Because the third row has a 0 in it. I'm just bad at math. The third row should be easier. It's just apparently not for me. Okay, so we got our determinant of -4. Now, if we're following along with the way... It's fine, Jed. We got the right answer. This is enough work without doing it multiple different ways. All right, let's set up the minor matrix. I don't know if it's actually noted like that. I'm just gonna do it though. All right, so the first element, you block off the rows and columns that involve that first element. So we get 0, 0, -4, -4, right? And then you block off that and that. 2, 1, -4, -4. Oh god, this is my worst nightmare. All 2 by 2 determinants that I apparently can't do. All right, that one and that one. -1, 4. I say, you know, I am learning something new though. So I've never done this way to get an inverse before, so you know. I feel like I'm doing karate whenever I do linear algebra, but I need to actually like visualize what the rows are like. Wait, who is that? Hardlocked. Thank you so much. In my time of need, you give me a husky scream. Oh my god. Thank you so much, Hardlocked. I appreciate that. Oh, the middle column is even easier. You're right, Gilbert. It's too late now. I'm not going to redo work, but yeah, you guys are absolutely right. Thank you so much, Hardlocked. I needed to hear that dog scream, too. All right. Dude, this is... Can anything in linear algebra just be quick to calculate? Like, what the heck is this? All right. So yeah, this one, thankfully, this first one is just 0. We do have a good amount of zeros here. That'll save us work. Okay. -8 minus -4 is -4. That's 0. That's +4. That's +16 minus 4 is +12. That is 0 minus -1 is +1. That is +4 minus 0. That is +16 minus 8 is +8. That is 0 minus -2 is +2. Okay. Okay, so we just transpose that, divide by -4, and we have our inverse. Let's freaking do it. Where am I going to do it, though? So the adjoint of D is just that transposed. The diagonal is going to stay the same, right? The 4 and the -4 will swap. The corners will swap. The 8 and the 1 will swap. And then D inverse is that, but you divide by the determinant, which is -4. Wait. No transpose? You turn the signs, really? Transpose and flip the signs. Más menos, más menos. So I was going off this site, which says to get this cofactor matrix. Oh, wait. Oh. I already transposed before. So, okay, I guess I do need to flip the signs according to this pattern. But it's saying to then transpose it too. So, okay. So I... Okay. I'm going to stop labeling things. I don't know what things are called anymore, but okay. So, and then it sounds like you agree. We do need to flip the signs and then transpose. Turn the signs. Okay. Oh my God. Okay. All right, let's make some... Actually, okay, let's just do it here. So we flip the signs, plus, minus. Okay, so plus 0 is 0, minus -4 is 4, plus 0, -4, positive 12, -1, positive 4, -8, positive 2. Okay, so that's the sign flipping that we need, I think. And now I think we transpose. How much room do I have here? Well, oh, or not. So that's according to the website. It looks like we're supposed to spot, but again, this isn't my my specialty, so. I guess you're right, Jed. Actually, no, it does. It affects which one. You need to divide the determinant. So, do we transpose at any point? Because we could divide by the determinant and then transpose. But at least, you know, let's. we're like one step away. Let's just see what. Actually, this should already tell us the inverse. 1/4. Yeah, I think we are going to need to transpose. Since Wolfram Alpha shows in a stupid way. That's the inverse right there. I wish that they actually multiplied in the 1/4. But if there's a -4 right there and no negative sign out front, I think we're going to transpose. But we can do it in whichever order we want for that part, I guess. Oh, I see the autogon at the top now. That's where that joke was coming from. Okay. Oh, and I didn't even see the solution is right there below it too. I completely missed that, but okay. I think D inverse is going to be minus 1/4 times that matrix transposed. We can do it in whichever, well, okay, let's just, never mind. But let's multiply in the the 1/4, the minus 1/4 first. So we're going to take that, divide it by -4. 0 stays the same. Positive 4 becomes -1. 0 stays as 0. And I think we need to transpose it still. -4 becomes +1. 12 becomes -3. -1 becomes +1/4. 4 becomes -1. 8, -8 becomes +2. 2 becomes -1/2. And so it's not going to match what Wolfram says if we don't transpose it, I think is the issue. Let's see. Oh, this. For this one, it doesn't matter the order. For that one over there, I think it did, Jed. I think that's our inverse. Okay, Spot. Let's test it. Because I think you're supposed to. Okay. Let's take our original matrix here and multiply it by the thing before you transpose, just to test your thing. We should get the identity here, but I think you're supposed to transpose. -1, 2, -1/2. Okay, so this is before we transpose. I think what you're saying the answer should be, but we don't get the identity. But if we do transpose and say my answer, then we do get the identity. So Spot, I think we have to transpose, otherwise we just don't have the inverse. I wonder if you learn it a different way where the transpose happens earlier? Maybe I just did it in a different order than you learned it? But at some point you definitely need to transpose, because otherwise you just don't get the identity matrix back out. So I don't know how you feel about that Spot, but I hope that makes sense. Solution you have is really? So the solution that you have, it was saying this matrix without the transpose? Because it doesn't work if you go and check it against the original. Okay, so you posted some more. Let's see what this is. All right, so are these? Did I bring up the same thing twice? Oh wait, it is just the same thing twice. Okay, no worries. Raise KD or sorry, Rake ZD. Thank you so much for the raid. What were you streaming? Sorry for the mispronunciation. You were doing math. Just finished studying Calc 3. Oh, well, awesome. I hope it's going well. Thank you very much for the for the raid. We're just working on a linear algebra question that's been a little bit tricky here. Some of it got an exam soon, so you're dropping. Oh, okay. Well, hey, good luck with the exam. If you can't hang out, no worries at all. Please take care of whatever you have to. What's happening here? Oh, okay, so spot. Oh, wait. Ooh. So they do say to transpose it where the inverse, in this formula, they have the transpose here. The way it's expressed is a little bit weird. But yeah, they did transpose it here. It's just a little bit hard to notice, but like the 0 and the 4, they're definitely flipped. So I think this answer agrees with mine. Yeah, it does. So my solution is the same exact thing as this one here. It just looks a little bit different. I guess you don't have to multiply in the -1/4, but I did. You see the error? Okay. It took me a second to realize like that this was the same too. I thought there was something off here. Okay. You see the error, so that's good news. Oh gosh. Okay, so should we look at B as well now? Solve the matrix equation CX equals A transpose times B, where A transpose is the matrix transpose of A. Okay, that seems... Yes. So it's very... Yeah, this... CX. Oh gosh. Okay, they're just giving... Wait. Oh God, this is... I see what we have to do. Okay. Do you want to see part B as well? Because I know how to do this one. It's going to be simpler than part A for me. It's still going to be annoying, but I'll happily do it if it would help you. I'll get started on it. So I'm happy to do it. I just want to make sure that you do like it's something that would like actually like benefit you to see. So, all right, let's erase this. This one's just going to be 3 matrix multiplications. Gotta be careful how we do it though. Oh my God. Okay. Good enough. All right. So, hey, Jackson Ford, how's it going? All right. So we have
the equation Cx equals A transpose B. We have to solve it for x.
And so our first step here should be left multiplying by C inverse. Very important that the C inverse goes here and not on the right side. So C inverse becomes the identity, which doesn't affect the value of x. And this is what we need to solve now. Just have to multiply all three of these because we know C, A, and B. I'm doing good, Jackson. Dr. Gold, yep. It's not my favorite thing, but we're doing it. So let's figure out what C inverse is, I guess. So if C is 2, 3, 1, 0, okay, at least it's a 2 by 2. If it was another 3 by 3 inverse, this would have taken a million years, but for 2 by 2, it's pretty quick. C inverse, so you divide by the determinant, which is -3. You flip those corners and negate the other corners. And we'll keep it like that. Yeah, okay. 3 by 3 inverse pain, it really is, yeah. I just had to do it in the last problem. It was not fun. All right, so that means x is equal to -1/3, 0, -3, -1, 2. A transpose is -2, 2, 1, 1, 0, -1. Times B with nothing special, 1, 1, -2. 0, 1, 0. Okay. We can do this. All right, so let's start with doing the kind of weird looking matrices here. That is what, 2 by 3. And this is 3 by 2. So that means we'll end up with a 2 by 2 matrix, and that's good because we have a 2 by 2 over there, and you can't multiply 2 by 2 by 3 by 3. So that would break reality, at least as far as I know. I don't know. -1, 2. What am I drawing? All right, this is going to be the result of the matrix multiplication here. So we take that column with that row, right? And that's that first element. So -2 plus 2 is 0. Wait, yeah. Yes, and then we get 1 times -2 is -2. Okay. Then we take this column with that row, and it's just the 1 there, so we get the 2 there. Okay. Now we do this column with that row. 1 times 1 is 1. 0 times that is 0. -2 times -1 is +2, so we get 3. Yep. Then that second row by the last, or second column, it's 0. It's 0. I can't talk, but it's 0. Okay. Okay, good. Now we multiply these two matrices. -1/3 can stay outdoors. That column, that row. 0 -3 times 3 is -9. That column, that row, 0. That column, that row, +2 plus 6 is 8. That column, that row, -2. All right, I'd say that's the answer, or you can multiply in the -1/3 if you're feeling fancy. 3, 0, -8/3, +2/3. Either one of those, I guess, would be your answer there. Does that make sense, Spot? That one's at least a bit more straightforward. Maybe I should check in Wolfram. Well, I see. It seems like you have the answer key, though. So maybe you can tell me if I'm wrong. Oh, gosh. No worries, Spot. All right. I'm only doing math for another 15 minutes or so. If you have another question, feel free to post it in that same thread. Otherwise, I don't see any questions from anyone else, so I'm gonna go back to studying, but I'll happy switch over and get through whatever math I can before I have to switch things over. Oh gosh, yeah. Okay, dude, linear algebra in general is just like exhausting. If it wasn't like so much work to compute anything, I think I might actually enjoy it, but it just takes so long to do anything. So okay, I think where I was before is Arnav, hey, over on YouTube. Nothing much up with me. How about you? I'm just doing some studying right now, but I'm always open for questions. Given a set X that is a proper subset of R that is connected in a function f maps R to R that is continuous, then f of X is also compact. Wait, also compact. Is this phrased right? X isn't necessarily compact. Well, no. Yes, it can be. Oh, and it's also connected. That would make okay, and that's going into what you were saying, SPQ, where if X is connected, then a function of X is also connected. Tushar, hey, how's it going? Dude, there's been a bunch of new people over on YouTube, and I'm all here for it. Thank you all so much for being here. Also on Twitch, but the YouTube thing is kind of new. It's a whole new world. I don't even want to think about this right now, to be honest. That might be one that I just look up a proof for or something, but dude, my brain is still hurting from linear algebra. The definition of compactness and then prove or disprove the following statement. Given a set X is a proper subset of R that is compact and a function that of F, a function F that maps R to R is continuous, then F of X is also compact. Oh, maybe there was like, that's where the typo like came from. So my mind here immediately, oh no. I was going to say like f of x equals 1 over x, but then we're not mapping all of R. We're excluding 0. So that is not a good counterexample. I assume this is true, but it's... I guess it makes sense. If it's continuous, that implies that the limit exists. Well, the whole of R is not compact either. Right. Like negative infinity to positive infinity isn't compact. Well, I guess it is technically closed, but X equals R. it is continuous, but R is not compact. Well, X isn't compact though. Right? We have to start with a compact set, I think. For 4? Oh, okay. For 4, we're guessing that it's supposed to say connected, and that compact might be a typo. But yeah, I think for as it's written, you're probably right, Gilbert. So pepper 1, yeah, we have a definition of compactness is closed and bounded for the sake of this class. And Arnav, I see you posted a question on YouTube. Perpendiculars are drawn from the points on the line x plus 2 over 2 equals y plus 1 over negative 1 equals z over 3. Oh gosh. Simultaneous plane equations. Ooh. So I'm going to copy paste it over to the Twitch chat just so they can see it too. What the heck? I haven't done a problem quite like this before. I'm trying to work it out. So I assume we're gonna have to use the fact that planes are defined by their normal vectors. So the normal vector for that plane is gonna be 1, 1, 1, taking the coefficients of x, y, z. And I think negative 1, negative 1, negative 1. Because there's technically 2 normal vectors for each plane. I think. The feet of the perpendiculars. So they need to be parallel to that. They need to be drawn from that line. X over 5. So we have to. What's the actual goal for this, Arnav? Do we have to find the equation for the perpendiculars, or find like the form of the perpendiculars, I guess? Or I guess I'm not sure what the goal is. I think I understand what's happening. I feel like it might be okay. Let me look up, see if I can find a similar problem here. Perpendicular from a line to a plane. Medcode. Can you do math in French? I cannot speak French, but if you post a problem that's in French, I might still be able to understand it just by looking at the math. I will say there's on the website Twitch, there's a math streamer who does speak French, Pen Center. It's going to take a second for the list to pop up. Oh gosh, I only have five more minutes on the math stream, and then I do have to switch. I'm gonna... shoot. I kind of have a hard stop in a few minutes here. But yeah, I'll list people that are posted there. Pen Center in particular from that list can speak French. Wait, is Pen Center not on the list? Wait, why is Pen Center not on that list? Oh God. Let me get a link to Pen Center. That's bad. Is there... Oh, it might be because of the character limit. Shoot. I have to fix that. That's Pen Center. So yeah, Medcode, I'm so sorry. I don't think I'm gonna have time to do another question today. I do have a Discord. If you want to post it there, I'll get back to you offline. Actually, I might have seen your name pop up as already having joined. Yeah. So If you don't mind, you can feel free to post your questions here, either in French or English, and I'll do my best to get back to you as long as I can answer it. I just made a little thread for you. And I'll get back to you offline. Yeah, no worries. I'm not gonna be able to get back to you like today. I'll be back tomorrow. Starting about like 2 hours ago, but I'm starting to run out of time to do math for the day. Shoot. And then who's asking me this one? Oh yeah, Arnav. So that's intersecting in a line. Oh, do you have to find the shortest perpendicular, Arnav? Because I'm kind of struggling with, like, if you have to find all the perpendiculars, that's... I don't know how you would do that. So yeah, med code for your question, I see it. I'm gonna have to take a closer look tonight, like in a few hours, and I'll get back to you off stream. I'm sorry that I won't be able to do it today. Or it's like on stream today. But I'll message you back with what I can find. All right. Thanks for understanding. Oh, shoot. I wish I could figure this one out faster, but I promised that I'd switch over to games at 3. Arnev, are you in the Discord as well by any chance? This might be another one where I need to work on it offline. Actually, it almost definitely is because we're getting to time here, and I'm not figuring it out quick enough. I don't think that's gonna be what I want. So yeah, Arnav, I guess the other thing I'm struggling with is I don't think it's a general. It sounds like the way that I was interpreting it is you need the equation for all the perpendiculars or something, but I don't think it's possible to get an equation like that unless you're talking about a perpendicular plane. So I guess, Arnav, I'm also having an issue of interpretation here, which is, do you need to find the plane that's perpendicular to the given plane that passes through that line? Or do you need to find just the distance from a line to a plane? Oh, sorry, I'm talking to Arnav, a different person. Not you, Medcode. Um, shoot, and I wonder if Arnav maybe clicked off. Oh wait, I'll send you the solution. I didn't even see that. Ah, shoot. Yeah, it's kind of time for me to always cut off the YouTube stream. How does this work at Arnav? Okay. I was gonna type to Arnav as well to see if they see the chat. Maybe they have the stream on mute. Same time tomorrow. To get to figure it out. To figure it out. Okay. So yeah, I'm gonna cut the YouTube stream off here because I'm gonna go and play games. And I promised someone else that I'd be on at this time. Let me see if they're around. Now, if you're good. Let me see if make sure the person that I'm going to play with is actually here. If they're actually not around, I can spend a few more minutes on the math, but. All right, actually, they don't seem to be replying. So, okay, I guess we can spend a few more minutes trying to find the answer. Actually, I feel like I just need more information from Arnav, to be honest, the more that I think about it. So at least, I guess I won't cut the stream off quite yet, but I'll take a look at what Medcode's trying to do and see if I can figure it out relatively quickly. Ooh. Why isn't this working? Paste from clipboard. All right, I got actually 5 minutes. Why isn't this working though? There it is. All right, so let's see what Google Translate has to say about this. All right. Consider a non-zero vector at a point on the planet K. Okay, yeah, this is not a perfect translation, but. Oh, God. I think honestly the French might be easier. jeez. Let B the point of the plane such that AB equals something, and we consider the point H on the line AB such that AB... Is that dot? Huh. I feel like I half understand what's happening here. It's this little dot that I'm a little confused on right now. Mm. Okay. I think I'm gonna figure this one out. I might at Pen Center and see if Pen Center has any ideas on this one though, because I'm having a hard time reading it. It might be something that Pen Center knows, and Pen Center speaks French anyway, so. Okay. Okay, see that Malcolm's ready now. Okay, I'm gonna switch over now. If you're here on YouTube, thank you so much, but I'm gonna cut off the stream here. I'm gonna stop doing math for the day. I'm gonna still stream over on Twitch, but it's gonna be playing video games. It's been a lot of new faces on YouTube, which I love. I'll be back tomorrow at 1 o'clock Pacific time, which is 2 hours ago, whatever that is in your time zone. And thank you all so much.